learners. Today's topic, solving inequalities. Solving inequalities follows the same procedures as solving equations, but there are a few special things we have to consider when we're dealing with inequalities. We need to look carefully at the inequality symbol. Guys, don't tell me sign, it's a symbol. Signs are negative and positive. Inequalities are symbols. We also need to graph the solution because there is more than one answer in an inequality. So we have a set of answers. There is more than one number that's a solution. It means we have a set. Okay, so let's review what inequality symbols mean. Okay, we have a greater than sign, we have a less than sign, we have a greater than or equal to sign, and we have a less than or equal to sign. And you know, when we look at these signs like this, we read it from left to right, just like we read English. I can take the exact same symbol and turn it upside down, and now I have a less than sign when I'm reading it from left to right. So that is really important that you don't tell me, oh, the big end chomps on the alligator chomps. No, I want you to understand what it means, because 2 being less than 5 is still the same thing as 5 being greater than 2. Those are two true statements, even though one is a less than statement and one is a greater than statement. Now, let's talk about how to graph the solutions. Okay, when we have a number that is greater than, we want to look at the fact that we have an open circle, okay, and the line goes to the right on our graph. So don't go around telling me that the inequality symbol told you that it was pointing to the left, so you're going to graph to the left. You need to make sure that you understand what that symbol says, and that if it says greater than, okay, if this, you need to make sure that you are paying attention to what it is talking about and not the direction of the pointing. Okay, if you graph any number that is less than, okay, it's going to give you an open circle, and you're going to graph to the left of that dot. Okay, graphing any number greater than or equal to means we have a closed circle. That means you color in the dot, and you are graphing to the right. And graph any number less than or equal to, we have it still a closed number or closed circle, and graph to the left. This statement right here is why it is colored in, because we are including that endpoint. So I came up with this really cool little graph here, and the anchor chart's on my wall somewhere too, that if we're looking at greater than, we have open dots, and if we're looking at greater than or equal to, we have closed dots. Now there is a thing called interval notation that y'all will have to know. All right, so if I take something that has a closed dot, let's say that was at 3 is greater than, no, 3 is less than all the things that I want, okay, that there's another way of writing it that requires less symbols to have to be used. And the other thing I want you to make sure that you understand is that infinity is a direction. Infinity is a direction. Okay, on a number line, if I'm going right forever, I'm going to positive infinity. If I'm going left forever, I'm going to go to negative infinity. So those are directions, and we need those when we're dealing with inequalities, especially in interval notation. So what matches up to an open dot is a parenthesis, okay, next to the endpoint. What matches up to a greater than or equal to or a closed dot is brackets. So let's look at a problem. I'm going to do the very first one, and you get to do the rest. Okay? So the first problem says I have this already graphed. Okay? I have 0 with a closed dot, which means 0 is the smallest. And closed dot says I'm going to have of the equal to, and it is going to go on forever and ever. That is my set notation right there. Grab this, clone it, and I'm going to slide it over here. So there's my set notation. Now my interval notation. Interval notation says I have 0 and I have a bracket. And instead of having the letter X, I'm going to go on forever. And I just told you going on forever in the right direction is positive infinity. And it always gets a parenthesis. Always get a parenthesis. So here is my interval notation for that first problem. Okay. Let's look down at this bottom one. I have this one right here. We're going to talk about this one, right? This one right here. We're going to talk about this one real quick. All right. Now, what that says is that if I want to write set notation, I have an endpoint of 2, okay, which is smaller than the x's that I have, which are still going to be smaller than 5. So there's my set notation. So there's my set notation. My interval notation, okay, well, open dot, 2, 5 is the other endpoint, and it has an open dot. So there's my interval notation for this one. I'm going to leave the other 2 for y'all. Okay, there's some more work for you to do. Practice graphing it, and writing it in interval notation. Now let's solve an inequality in one set. Okay, solving an inequality is just like solving an equality. There's only going to be one situation we're going to have to watch for. So let's solve this little inequality. I'm going to put up my line like I do, just like in doing equations. Okay, first thing I'm going to do is I'm going to subtract 4 from both sides, just like we would if it was an equation. Okay, I'm not going to change my inequality symbol. All right, now what I have is x less than 3. Okay, now I'm going to graph the solution. But looking at that, I have an open dot at 3, and the line says that all my x's are smaller than 3, so that means I have to graph the line to the left. And there we go. One more quick one. There's one special case. All right, sometimes you may have to reverse the direction of the inequality symbol. And this only happens when you multiply or divide both sides of an inequality by a negative number. For our example, okay, I'm going to subtract 5 from both sides. All right, I'm going to divide each side. Let's subtract 5 from both sides. All right, divide each side then by 5, or by negative 3. Okay, now I'm going to divide by negative 3. And when I divide by negative 3, I have this special situation. I have to reverse my negative sign. I have to reverse my negative sign, so my new answer is y is less than negative 6. I reverse the negative sign, graph the solution, open circle, line to the left. If you have any questions, feel free to write them down. I want you to try these for me for homework, and when that's said and done, y'all are done good. Proud of you. Bye.